This is the figure from box 2-2 in the textbook, and here we are looking at a positive feedback loop. Now think back to last week when feedbacks were introduced. Now a positive feedback, remember, has an amplifying effect. Now we are looking at the impact of changes in albedo and temperature on Earth's surface. Now remember, albedo is the proportion of radiation reflected back from Earth's surface. And in your book, table 2-1 shows the albedos of different surfaces. And remember that fresh snow and ice have really high albedos. So if we start here, there's going to be some initial change. And we have a cooling climate. So if you get a cooling climate, you're going to get an increase in snow and ice coverage over Earth's surface, which is going to greatly increase the albedo. So it's going to be increased reflectivity. Remember that water is really great at absorbing radiation. So if you cover that water with ice, you're making a huge difference. So now we have an increased reflectivity, therefore an increased albedo of Earth's surface. So then, because of that, by definition, Earth is then absorbing less solar radiation at its surface. It's reflecting more back into space, and because it's reflecting more light, it's going to even continue to cool further. And what happens when it cools further? You're going to get an increase in reflectivity and an increase in albedo, and it would carry onward and onward and onward, creating a positive feedback loop, amplifying its effect. Now also in your book, there are similar feedback loops shown for water vapor and also for plant climate interactions. And I want you to go through those carefully, and it might be a good idea to post your interpretation of them on the forum and get some feedback from your peers.